Hi, teacher, and hi, friends. I am Bilge. Today we will present our initial model. I would like to quickly remind you of our data set and start the initial model presentation. And this is our data set. The name of the data set, Lending Club Loan Data. The set contains information about economic profile and history of people that already took loan from Lending Club and their study of loan as a binary class. Our aim was preparing a machine learning model that predicts a loan, a broad customer or not, according to customer economic profile and history. And our motivation is, okay. The Lending Club desires that when the new customer arrives to apply to register Lending Club, the company wants to predict that if the loan is given to the customer, would that customer pay back its loan fully or that will be charged off? And this is our information about our data set. We cleaned our data set as we in EDA. Now we have 135K sample. And this is our feature description of the data sets. And now you can see our data is fully balanced. I want to tell you what kind of work.
Bilge, are you sure that your data set is fully balanced?
After cleaning, yes, teacher.
After cleaning, okay.
Yes. I want to tell you what kind of work we did do after EDA presentation. From feature statistic, we looked at the minimum and maximum values of the features. Based on these values, we noticed that the features that have very high values, such as installment and annual income, as you can see, have high values. We perform some transformation operations to reduce these values to a smaller scale. So we try to produce new features. When we send our data to the model in pure way, we saw that there was an underfit condition. When underfit, there were two possibles, either to strengthen our trained data set, like adding more features or adding more samples. Or the second option is to increase the complexity of our model. We tried the second option. We didn't get a good result when we played on the hyperparameters. We decided to return to the first option and produce new features since we cannot increase the number of data samples. We tried to increase the number of features and approach the data from a different perspective. Later in the presentation, we will talk about how we produce our features. Can you go back, Bayram, to our IS? This is how Orange Workspace looks. As you can see, we worked on linear models. We used a naive base and KNN as a baseline models. These have been a base for us. You can continue, Bayram. First of all, I would like to tell you how our data looks before preprocessing. As you can see, some of our features have very high values. We wanted to shrink these values before sending them to our model. As you can see, some features are time dependent. For example, early CR line and issue date. We also removed the grade feature because our subgrade feature is was more informative. We talked about in EDA presentation. In the pre-processing process, we normalize our features. You can continue. Yes. We choose normalize to the interval 0 to 1 because we learned that it works better in the 0-1 range for regression because our problem is regression.
Bilge, which kind
Yes.
of models prefers this kind of pre-processing?
Linear regression, I can say.
For example, what about decision-based, tree-based algorithms?
I don't.
Do they care about the scaling of the features? Values?
Yes, I don't think 0-1. Maybe we can standardize to the first option, but I didn't do tree model. My friend Umay did, because now I'm presenting some linear models and Bayes models to you,
But in
teacher.
the class discussions, we
Yes.
spent a good amount of time for that, right?
I can say it's standardized to first option for tree. I remember you said like that, teacher. I don't think.
Okay, what about the other team members?
I think Bilge confused about that. In the tree-based models, there is no need to pre-processing. Actually, we talk like that because it does not need any scaling. It's directly found its probability. So it's working like that. I remember like that.
Actually, not probability Bayram, but it can ask the question like greater than this, less than this, so it can adjust itself for the
It's asking
different
some
scales.
questions.
Yes. But as Bilge suggested, for the linear models, you need to normalize or rescale the feature values. But for the tree-based, you don't need. Okay, let's continue, Bilge.
We used continuous discrete variables budget. It applied one-hot encoding for our values such as subgrade A1, A2, A3, which helped us to get high results. You can continue, Bayram. You can see right after pre-processing, our values, if our features are normalized, like loan amount, it was very high. It has very high values, and you can see the grade A, grade 0, grade A, grade B, grade C. These are one-hot encoding. You can continue. Yes. And the test and score, you can see the results here.
Before getting to test and score, could you please go back a couple? Yes, one more. So in that one more, you also scale the loan amount, right?
Yes.
Okay, in real life, for example, after training this model, if the bank asks you some questions about if this guy will pay completely or charge off, and the bank will provide you some information, for example, loan amount. But at this time, in the test or the real life case, the loan will be, for example, $100,000. How can you convert this nominal value so that your model can use it? Because now your model is trained with the loan amount between 0 and 1. Do you understand my question first?
Yes, but not 0-1. I didn't add, I think. It was 2, 3. not 0, 1.
Okay, then you just, it is a normalized one. Okay, but
Yes.
it's not the nominal value, what I mean.
Yes.
It's not real value that in the data set. But in a bank situation, if you deploy this model in a bank, but in real life, people are not getting 0.446795. They are
Yes.
getting, for example, $120,000. But you cannot give this number to your model because your model is trained with, right, 0.1567 kind of numbers. How
Yes.
can you use the real life information to make the prediction? Any idea?
Maybe I shouldn't normalize this feature.
No, it's okay to normalize. It's a common practice. Actually, what you need to save these. Bayram, do you have any?
Yes, but maybe we can just pre-process on the train data. So the test data, it's automatically pre-process.
In real life, I am asking in real life situation.
In the real life situation.
Not train test. I am asking the real life situation. So you need to save these transformations. And when in the real life situation, you need to apply the same transformation onto real data.
Yes,
right?
Okay. You're right, teacher. You can see our result, teacher. I can't say it's perfect result, but we had some transformations and we had some features to achieve the best results. Now my friend Umay will continue.
Okay, Umay, when you look at the evaluation results, so first of all, I think you look at the classification accuracy, right?
Yes.
So how many options in that classification problem?
What do you mean? What options?
What kind of a classification?
Binary classification,
Okay.
multi-class.
Not multi-class.
Multi-level. In
your
binary. Binary
is,
classification.
Yes, it's yours is binary classification.
Yes.
Am I right? So
yes.
you have only two options.
Yes.
So the classification accuracy is around 0.5. Do you think that it's a success?
No.
It's a random choice, right?
Yes.
Okay. Let's begin.
Hello everyone, my name is Umay. Today I'm going to present decision tree algorithm and random forest algorithm. As you can see, there is 5 options in tree widget. In this binary tree, build a binary tree split into 2 child nodes. Minimum number of instances in leaves. If checked, the algorithm will never construct a split which would put less than the specified number of training examples into any of the branches. Do not split subsets smaller than 5. Limit the maximum tree depth is 100. Actually, we were trying to optimal classification accuracy, but it's not successful. As you can see, classification accuracy in tree model, in this model.
But why you didn't share us with the trade accuracy? That's on the test accuracy. Where is the trade accuracy?
Train accuracy is first right side.
No, it's test on test data, what?
Upper side, it's actually in the model we sent only the train data, but
I see. You mean that in your flow, you
in the
sent
flow,
the train data 2 times, right? Twice.
Yes. Can I, again, if you can see, I can share my model in orange tree widget.
Okay, we can see the end of the, because we have already got out of time. Let's do.
Okay. First, train accuracy. Second, test accuracy. As you can see, there is big difference. Next slide, please.
So what's your comment about that?
It's not good solution. It's not good result.
What about you, Bayram? What is your comment on that screen, on that result?
We are dealing with a highly overfit issue. And
For example, what? Which model?
for example, for the 3.2, it's highly overfits because
What about 3.1?
in the 3.1, it's underfit actually. So we couldn't generalize our data set as we expect. We tried many methods. I will share our strategies in the next slides, but always we are on the edge, and we can't generalize only the one. How can I explain? Only we get underfit situation and the overfit situation. We couldn't find the generalized solution in this up to now, actually.
Okay. So, Bilge, for you, the tree model and
Yes.
the random forest model, if you check this, do you think they are overfit, underfit, or just fit? Which one?
I think a 3.2 is overfit due to depth, I think.
No, I am asking just tree and forest two. Random forest two. Tree and random.
I think a random forest more generalized, I can say, but tree was not a good idea for our data sets.
May I add something?
Yes.
As a group, actually, we worked on pre-pruning at the beginning of the three models, because in the default parameters we saw in the 3.2, there are highly overfit data. So we tried to pre-prune the data with these three minimum number of instances in this do not split subsets. We try to increase this data and decrease the tree depth. I will explain in the later to decrease the train data set, but always we get bad results on the test data. We couldn't achieve higher than 66%. So I don't know why.
Umay, on the left side, I see three orange, but which three orange or which tree model this parameter belongs to?
We see model 3, just 3.
Or
Second 3.
Or
Third 3. I'm sorry, third 3.
So you need to give proper names to your objects.
Yes.
You didn't provide any names.
Yes.
You just right click, and give the name, change the rate, right 3, or on the right side, the test and score should be renamed, right?
Yes.
Like test result, trade result, blah, blah. So when I look at this screenshot, I don't understand clearly which one belongs to which one. In your reports, update these.
Okay.
We will be careful about it.
Okay, let's continue, Mah. A little bit quick.
I have played with the hyperparameters.
Not play. Tune.
Excuse me?
Not play with. Tune. To tune. Not play. Tune.
Okay.
The terminology is hyperparameter tuning, not play.
Tuning, okay. When we tuning the hyperparameters, we get these results in decision tree algorithm. Decision tree algorithm tree does not use any pre-processing. Actually, we pruning to getting an optimal decision tree. Pruning is a process of deleting the unnecessary nodes from a tree in order to get the optimal decision tree. Can you? Yes. Random forest algorithm is a popular machine learning algorithm that belongs to supervised learning technique, which is our problem is supervised learning in binary classification with charge off or fully paid. Random forest, actually it is default random forest algorithm. Can you go back? No, I want to share first random forest algorithm. Yes. As you can see, classification accuracy is 0.7 and 0.8 and 0.6. Next slide, please. When I increase number of trees to 500 and do not split subset smaller than 10, results are changed. Train accuracy is higher. Test accuracy is smaller than first one. Next slide, please. Again, we tuning the hyperparameters and get these results. Next slide, please. We select random forest and tree because of banking and land use. In machine learning, they use random forest and decision tree first. Actually, logistic regression is too. Sorry, I have a health report actually. I'm not quite well. Bayram, let's continue.
I has a little bit headache, sir, so I cannot focus on. Well, okay. In the next decision, according to our work, we see these results completely in the trained data set with all models that we worked before manipulations that we worked on. And we see that tree and random forests are quite good to response our tuning, actually. The other linear methods are not response well or giving any response to changing the hyperparameters. So we worked on tree and random forests.
Bayram, I have difficulty understanding what are these numbers. Which one is trade, which one is test. I cannot answer. Everything is the same because for me now.
I see. So in the top of the
first slide.
In the first part, it's completely trained data set results.
Okay.
And at the bottom, there's a test data metric results, sir.
Okay, please rename these objects accordingly so when we look at and we can understand.
Yeah, I see, sir. These are the optimized. Model. I would like to tell.
But on the left side there are 3 models. On the right side there are 4 models.
Yes, we separate them because in the linear models we worked on pre-processing with scaling, and in the left side there is no need to pre-processing. So we worked on different widgets, different test and score widgets. So we need to separate it. And
No, I am saying that one has 3 models, the other has 4 models. Three random forest naive bias, but on the right side you have Keenan as well.
Yes, sir. The KNN, SVM, naive bias.
So why don't you have the Keenan on the left side?
I see, sir. Yes, we did it.
What's the reason for that?
We worked together. We worked on also we made a scaling in the KNN to work safe, sir. So in those in those models we worked on scale. We scaled the data, but in the left side models we didn't use.
Okay,
scaling.
I understand, but you can use Keenan on the left side. Am I right? With the same data. Why didn't you use the Keenan with the unprocessed data? What's the problem with Keenan? Why didn't you use?
Actually,
You forgot it.
Yes, but as I remember from the course, to be safe, to work safe on data, we need to scale. So we scale.
But I am asking that Keenan will work with any data. Am I right?
Yes, sir. Yes. Sir.
Why didn't you use on the left side? So we can compare the result.
Yes,
but we cannot compare Kienan's results.
Yes, we forgot that point.
Just say that we forgot it. Do not further discuss. Just say, oh, we forgot it, we will fix it. That's the answer. Why you try to make something so complex?
Yes, I'm sorry, sir.
So what you see in that graph, give me one statement, the important statement, not the numbers.
Okay. As you see in the logistic regression on the right side, there is a typically an underfitting response, and these results are not changed according to the hyperparameters that we worked while on the logistic regression. So we see that linear models are not quite work well for our model. So in the next stage, we will discuss about the tree-based, tree and random forest models, because with the pre-pruning we get some responses, but in these models we are again in the underfitting, but better than the linear models. As shown in the right side, you can see in the logistic regression, 65% and 65% they are equal, and also in the SVM they are similar, and they are very
okay
bad.
Okay, let's move on. We have only 10 minutes.
Okay, sir. So we worked on the decrease the complexity of model to avoid overfitting for the tree model and tree and random forest models, because we get 90% of train and 60% of test. But in the pre-pruning, we couldn't get well results, so we tried to increase the data according to the features. There are typically, we found 3 ways in the discussions using PCA to dimensional reduction to the correlated, according to the correlated features, one-hot encoding, and adding new features according to the feature statistics. In the first discussion, we used PCA on model, but we didn't see a quite well. There's no any difference between the with PCA and without PCA. There's a very small difference, as you see that. According to the correlation widget on the orange, we set components on the PCA as 10. We set as 10, and we would like to create 10 new features according to the correlation of those features. But as you see that there is a overfitting issue mostly in the 81% and the 65% means overfit for our data set actually when we compare with the default. So these are not good results for us. In the test environments of combinations of PCA, adding new features and one-hot encoding, we used these three models actually to see the results, what we will going to have. In the adding new features, we use feature statistic widget to see the minimum and maximum values of the features. And we try to decrease the scaling of some, we try to transform some features with the non-linear functions, for example, logarithmic functions, to change the shape of the figures, change the shape of the graphs to
Actually, you don't need to do this, because if you use what kind of model you can do this automatically, Bilge? For nonlinear transformation, what kind of models supports this kind of operations automatically, Bilge?
I can say maybe linear.
No. Umay? What kind of model supports these nonlinear operations?
Non-linear decision tree, for example.
No, I am saying nonlinear transformation is supported what? You are replying with linear. I am asking nonlinear operations. You are saying linear. Bayram?
Non-linear.
Non-linear.
No, SVM, kernel SVM supports this.
Yes.
In kernel SVM, we have the kernels. So they
Yes.
do this automatically. We have discussed this thing in class. You don't need to do manually. If you go to the SVM widget, you can click and select a kernel over there. This kernel will do it automatically for you.
Yes, sir.
Okay, let's go to you.
We tried the SVM, but we get bad results.
I am not asking SVM. I am talking about
kernelized
SVM.
I'm sorry for my.
Okay. Let's continue here on the 3 minutes.
Actually, at the end of the day, actually, these are not give any information to us. Actually, we couldn't generalize our data sets in the first stage, first initial modeling. So actually, we would like to get some feedback. How can we go forward, or what we can do in the next stage, because we couldn't.
What you suggest to do next step to improve the accuracy of your classification? What would you do?
Maybe we should increase our data sample, because we change our features and it didn't help us. Maybe we should.
You already 135K instances, right? Sample, so it's very big number actually.
Yes, maybe we should try different strategies to our features, maybe?
We worked on, sir, according to the EDA, as I mentioned in the EDA, we made a filter to delete the features about in the on the subgrade feature. We delete between B1 to E5 to increase the accuracy, because there is a high accuracy when we see by our eyes. But when we do that with the filtering, we see a increasing, but very small, about 2%.
Okay. So Umay, for you, Umay, what would you do?
In lecture, you said that sometimes you should look your problem differently, ask different questions. Maybe it can help add some context to our data, maybe help. As Bilge said, increase our sample number, maybe help.
Okay. Any other ideas?
Maybe we could focus on different metric, but I don't know.
Metric wouldn't change the result, right? Metric wouldn't change the result. So,
actually, I researched yesterday for our presentation, and cross-validation is a technique used to enhance the model.
actually, they do not enhance the model, but they just show you the insensitivity of the data for each model.
Yes.
But actually, they do not. If your data is less comparatively, you can use the K-fold, but your data is not so few. Actually, there are 135K samples. It is not less, and you have 86 features. So I think you can use the PCA better, and you get better because you have 86. And normally the linear algorithms should be overfitting, but in your problem, you cannot remove the overfitting and you cannot get just fit level. But there is some problem. I think you need to focus on 7 ones. You can work on with kernelized SVM and try to use the kernels accordingly.
Yes,
Okay.
we will try it. If you are available, we would like to discuss about our model.
We are just discussing right now, so you discuss right now. So if you want to
there
say
are 1
something,
minute left, or
okay.
so I couldn't.
So,
actually, we have totally 24 features. This value is about